identify the vertex, axis of symmetry, and x-intercept. Okay, so this first equation is in vertex form, so it already tells you what the vertex is. So as we look at it, we know that this is x minus h and squared and then plus k. So the h and the k are coordinates of the vertex. So looking at that, we can see that the vertex is equal to -3 and -1. Remember, when you have a positive there for the h, if it's plus, in this case +3, that means minus negative, so our h is actually negative. But the k, we just take straight the sign that we see. Okay, so let's plot that, -3, -1. So right there. Okay, so we also want the axis of symmetry, and the axis of symmetry is just that vertical line that goes through the vertex. And actually, once you know the x-coordinate of the vertex, you already know the axis of symmetry, because that's just x equals -3, because that's the equation of a vertical line. Also the x-intercepts, okay, the x-intercepts are where y equals to 0, so let's just set y equals to 0. So let's just solve that using square root. So the first thing, add 1 to both sides. So to get rid of that square, we take the square root of both sides. So square root of 1 is just 1, but remember it's square root of a square, so plus or minus 1 equals x plus 3. And so now just subtract 3 from both sides. So we're going to get -3. Put it in front of the plus or minus. It'll make more sense when you solve this. So x equals -3 plus or minus 1. So let's figure out the two x's. We have one of them, -3 plus 1 gives us -2. And -3 minus 1 gives us -4. Okay, so let's plot those 2 points. So we have -4 and -3. So there we go. Let's just find one more thing. Let's find our y-intercept so we can exactly know where the graph goes through the y-axis. So let's plug in 0 for x. So we have 3 squared minus 1. That's 9 minus 1, and that's 8, equal to 8. So 2, 4, 6, 8, right there. So we know it has to be on this side also of the axis of symmetry. And right there is our graph of this equation. Okay, also graphing the second one. Now, this one is in standard form, so we approach it a little differently. So we want to find the vertex first. Remember, the vertex is, the x-coordinate is equal to -b over 2a. So let's plug that in. -12 over 2 times a, that's 4. So this reduces down to, if we reduce it by 4, we get 3 over 2. So -3 over 2, or also equal to -1.5, if you like that better. So let's make each one of the x-axis, each box 2, each box 1. Actually, each 2 boxes 1. So let's make this -1. Let's make this -2. 1, 2. Okay, so this is the x-coordinate, so we still need to find the y-coordinate of the vertex. So let's plug in the negative 1.5 into our equation. Okay, so plug this into your calculator to figure out what the y is equal to. Okay, so this comes out equal to 0. Okay, so our vertex is at negative 1.50 right there. Now, since the 4 is positive, the leading coefficient, so it's going to open up. Let's find the y-intercept. So let's plug in 0 for each one of these, but actually when we do, we know that the only thing remains is the constant that doesn't have an x on it, so the y-intercept is 9. And we already have our x-intercepts because there's only that one where the vertex is. If we think of the axis of symmetry, we can plug the point, we can plot the point on the other side of the axis of symmetry, 3 away right there, and now we can plot our parabola. Okay, so that's it. So we have the intercepts, the vertex, and the axis of symmetry, of course, is x equals negative 1.5. Since that's just the equation that goes through the x-coordinate of the vertex.